Now we're going to talk about our grade lines. Basically the energy line and the hydraulic grade line. Now what these are is they're just measurements of the Bernoulli pressure in the system. And you can look at things, the hydraulic grade line would correspond to pressure tap measurements plus whatever the height is. And the energy grade line would correspond to a stagnation pressure tap plus whatever the height is. So basically the big difference between the two of them is what they measure. So let's start with the first one, which is the energy grade line. So the energy grade line would be a measurement of Bernoulli's total pressure through the system. So if you were going to calculate out the energy line, so EL, we would be looking at pressure over gamma plus V squared over 2G plus whatever my height is. And that's going to be constant. So if you have a fluid that's flowing and there were no frictional losses due to the pipe or components that making you lose losses, and if there was no pumps or turbines adding or removing energy to the system, our energy grade line would be a constant line. In reality, our energy grade line is going to slowly, if there's nothing else in the system, so this would be perfect, and this would be real, our energy grade line is going to decrease because we will be losing some energy due to friction. The interesting thing about the energy grade line is, say if we have a pump and we have the fluid coming into a pump, so the energy grade line would degrade into the pump and then it would pop up by whatever energy the pump adds to the system. And so that's one way to pop up the energy grade line. The other thing would be is if I drove the energy grade line into a turbine, so my energy grade line would decrease when it hits the turbine, we'd lose whatever energy is coming out through the turbine. This is an interesting thing with the energy grade line, so we can see the energy as it is through the system at any different point. But of interest to what we're doing was going to be the other type of grade line. And that other type of grade line is what we're going to call the hydraulic grade line. So the hydraulic grade line is a little bit different because the hydraulic grade line does not take into account the dynamic pressure, that velocity head. And so this is representing the total head available to the fluid without the velocity head. So our hydraulic grade line, so HGL, would be just the pressure over the specific weight of the fluid plus the height. I use Z in the other one, so plus Z. So whatever the height is. So basically, how does the hydraulic grade line compare to the energy grade line? So if this is my energy grade line, EGL, my hydraulic grade line is going to come under it by the difference of one velocity head. So V squared over 2G, just straight out from our equation. Great. So how are we going to end up using this for what we're doing? Well, the hydraulic grade line is a good graphical representation of static head, so that stagnation pressure. But we can also use the hydraulic grade line to figure out which way the fluid is flowing. Because if HGL1 is bigger than HGL2, then the flow is going to move in the direction of falling hydraulic grade lines. And so if you do not know anything about a pipe, because I believe you can see on the ship's sight valves where you can physically see where the fluid is flowing, but you can't always do that. If you've got a sewer line underneath the ground, or if you have some pipes that are buried in some place and you're trying to figure out which direction they're going, you cannot just look at it and see which way the fluid is flowing. Especially if there is a web of pipes and you end up getting into a case where one pipe is breaking into 3 different sections, you're not quite sure where the fluid is flowing just by looking at it. But what we can do is we can easily put a pressure tap at each one of these areas, and then we can use that to calculate out which way the fluid is flowing, because we can just find out which is the highest HGL and it will flow to the lower ones. And so, who knows, it may turn out that this is the one where it's coming in that's flowing this way, and maybe this one's flowing down here, and maybe they're just all flowing in and then just flowing out there. But we can't do that based on sight alone, so we use this concept to actually calculate it out.